Hello everyone, in today's tutorial I want to show you how to create a flower with stem, blossom leaves and a stamen using geometry nodes. The flower can be closed, the radius of the blossom is variable, and of course the shape of the blossom leaves is flexible. Not every flower in the world can be created with these parameters, but I think at least certainly some of them. So if you want to know how to create that, just watch that video. So first of all, the grass that you have seen in the thumbnail will not be part of that video, but I have made a separate tutorial on that procedural geometry nodes grass, and I'll put a download link in the description below. So let's jump into Blender and we will start with our default cube. We will activate it and click on Geometry Nodes panel, and we will create a new Geometry Nodes setup. Disconnect input from output, and we are going to start with one single blossom leaf, and to do that we are going to need a quadratic Bezier curve. Quadratic Bezier, and we can set the resolution to 10, and we are not going to model our blossom leaf in real world measurements because I think it's very hard to model with the small parameters. We will create a really big blossom, and later on when we make some instances of it we will scale it down. That's much easier than work with these tiny millimeters parameters. So let's start, and I will create some curve with a start point, middle point and an end point. Of course you can figure out your own values, and you can later on change these values, but for the moment I will go with the values of 2, minus 0.3, 0, and the middle point will be at 1, minus 0.2, minus 0.4, and the endpoint will be at 0. That's important that the endpoint is at the 0 point, because later on we will bend and transform it, and if it's not at the endpoint at 0, 0, 0, it will behave a little bit strange. So let's connect it with the geometry node output, and there is our base for our leaf. By the way, these areas that you see here, these are my material layers. You can ignore them. Maybe I will blend them out just like that. So back to geometry nodes. We don't need the camera too. So that will be our blossom, and now we will need a resample curve node. The resample curve node will give us some extra resolution to it, so we can later on define a little bit the shape of our blossom. And what we are going to do now is create our leaf. And we will do that with a set curve radius node. And we will need a curve to mesh node. And what we are going to now is we are going to add another quadratic Bezier curve to give it that shape in the y-axis. So we can copy the quadratic Bezier from the beginning, and we will give it a profile just like that. And now we have to change the parameters. First of all, we're going to zero out everything, and now we want to change the start x value minus 0.5 and the endpoint 0.5. And we also want to change the set curve radius, and to do that we are going to use a float curve. And we need a spline parameter. Spline parameter, because we want to control the beginning, the thickness or the width at the beginning and the width of at the end. So we will plug in the factor into the value, and value goes into the radius. So what we got now, we got a radius from 0, or a thickness or width from 0 to full width. And when we now change our float curve, maybe something like that, you can already see that we can redefine the shape of our blossom. You can nearly create any shape you like to. It's just does that make sense? No. Because we want to create a daisy, I think we can go with something like that. You can later on change the thickness of your blossom with these two parameters, and to change them we will need a value node. Let's move that a little bit to the right. A value node, and we want to combine XYZ node, and we only want to affect the X parameter, so we will need that twice. And we'll plug that into the X parameter, 0.5. And because the upper one is a negative value, we will need a math node, which we set to multiply -1. And now if we connect these two, you can change the thickness of your leaf with that parameter. Now it's a little bit rotated. Maybe I've missed some of these parameters, but that's no problem. We can change that with a transform node and just rotate it. Just need to find the right axis. There it is. And now it's perfectly aligned. Yes, and the start point is exactly in the middle, at the center. So what we are going to do now is to add, because we want to have more control, even more control to the shape of our leaf, we will add a delete geometry node. But first of all, we are going to group these things, hit Ctrl J, and then F2, and we will rename it to blossom base shape. And this part here will be, hit F2, the blossom, I don't know, custom shape. I don't know if that makes sense. And to have even more control about it, we will add a delete geometry node. Delete geometry, and it deletes everything until we add some endpoint selection node. And when you set it to 0, 0, everything is shown again. And now if you change the start size, you delete the geometry that's up here. And if you delete the end size, you delete the geometry that comes from the start point. It will make more sense if we later on add some, I don't know, blossom stem to it. then you can see that the geometry is deleted. Now it still looks a little bit edgy, is that the right word, because it has edges. I don't know. Let's add a subdivision surface. And right after our curve to mesh. So add subdivision surface. And we've got some pretty cool looking blossom. I don't think you need a higher level than 1. 1 is enough, I think. And later on we will need a material, but we can do that now. Set material. But we will fill the material later on. That will be a separate part of the tutorial. And what we are going to now is to add some stem to the leaf. And to do that, we will create a set curve radius. Where is it? Set curve radius, and we will create that just above our blossom custom shape, and we will use the blossom base shape and connect the resample curve node with our new set curve radius node. And to see what's happening, we will create a join geometry node right at the end. And with the set curve radius, we will again need. I created that not by hitting Shift and right mouse click. We will need another float curve node. And we will need another spline parameter node. Connect factor with the value. And that curve radius. There you can already see that we have exact the same curve for our stem that the leaf, and connect the value with the radius. And of course we will need again a curve to mesh node, and we will want to give it a thickness, and we'll do that with a curve circle node. And connect that with a profile curve, and we want to fill the caps, and it's way too big. We have to give it a much smaller resolution, and we need, of course, much smaller radius, 0.3. And as you can see, we have some kind of blossom stem. I really don't know if that is the right word. And now we can also control the shape of our stem right here, but I think that was also already pretty cool. And now it makes more sense if we change the end size, because now you can see you have some leaf that looks naturally, because the stem has no blossom around it, or no leaf. And if we can change that, I think that does not make sense. We can leave that at 0, but if you want to create your own custom shape, you can later on play with these values. But for now, I will leave it at 1. And of course, we want to give it a material too later on. Set material, and we will fill that later on. And we will make a new group, hit Ctrl J and hit F2, and we will need rename that to blossom leaf stem, and because we want to deactivate it sometime, we will add a switch node, and now you can just turn it on and off. I will leave it turned off. And the next thing we are going to do is, let me see, we will going to create some kind of, I really don't know the English expression for it, the middle part of that flower where the pollen is. And to do that, we will go under our blossom custom shape. That makes sense. And we will create an icosphere. And we will connect it with our join geometry. So that's way too big. First of all, we are going to give it more subdivisions, maybe 3, that should be enough. And we will change the size. We'll go with 0.13 meters. That's at least the radius I've used in my presets, in my notes. And I think we can make it a little bit bigger, like that. And now we want to transform it so that it looks more like the inner part of a blossom. And to do that, we will need a transform node. Arrange that a little bit prettier, like that. And now we can change the Z scale. And we will go with 0.2 maybe. No, that's too much. 0.3. I think that looks pretty much like a flower shape. That's already too enough. 3.5. I think that's okay. And what we are going to now, we want to extrude these parts here, because it already looks like some flower flower distributed pollen. It does not look too uniform. There is certainly some kind of math to create that, but I think that's a pretty easy and good solution. Of course, if you want to spend more time in it and make it even more realistic, you can search for some math. For now, we will go with that solution, and we will need now an extrude mesh. And of course, it's way too big. We are going to set this to 0 first of all, and we'll only change it slightly. And as you can see, it extrudes every single face of that icosphere. And first of all, we want to make it a little bit more realistic, and we'll use some subdivision surface. I think we can go with 2, and that already looks a little bit more natural. But of course, we want to get rid of the shape on the bottom side. And now there is an important part, because that part you can use for any other tutorial or any other model you want to like, if you want to only extrude some parts of your mesh. We are going to use an expression that only extrudes the upper part of the icosphere, and to do that we will need a combine XYZ node. We will need a math node that we'll set to greater than. We will need a separate XYZ node, and we want the position of every face. And because of that parameter here will be really sensitive, we will need another math node that we set to divide. and we divide it with 100, so we can change that value here, and it will only have a slight change on the extrude later on. So now we connect the position with our vector, so we get the position of each face on that icosphere, and we connect the Z value with the greater than, because we only want to know something about the Z position of each face. Connect it with the greater than. Connect the divide mesh node with the lower input, and now connect that with the combine export Z node with the Z input, and that goes into the selection of the extrude mesh. And as you can see now, when you change that parameter, you can set some selection on which or what faces or areas of that icosphere should be extruded. It looks a little bit ugly, and we will create a set shade smooth node right at the end, so everything is set to shade smooth. To have even more control about that, we will add another extrude mesh node, and we will let me see. No, we will this check that. So now we have better control, or we have a better variety of shapes. I will show you soon. First of all, because these values here are very sensitive too, I'm going to add another divide node, and we can divide that by 10 only, and connect that with the offset. And as you can see now, we can create them some blossom or flower shapes, and with the subdivision you can even create even define how many pollen or however you call it, however what the right expression is for that. And if you decrease the subdivisions, they will get less. And with, let's connect that with that offset too, and with that one you have also some control about it. These two extrude mesh nodes have different influences now, but we can also connect the selection with the second one, and that will give us some interesting shape. I think we will go with the 3 subdivisions, and I think that one looks pretty cool. So I think we can go with that. So let's make a group around that. Hit Ctrl J and F2, and we will name that. I think we have to look up the real name. I will name it Flower Middle Pollen thing. So the next thing we are going to do is we are going to distribute the leaves around that middle thing, and to do that we will create a curve circle. Curve circle, and we are going to use the exact same radius that we used for the icosphere, and to have always the exact same radius we will use the group input for that one, and we will connect the radius with an empty slot of our group input and rename it. Yes, radius is okay for the sake of that tutorial. And going back to our flower blossom distribution circle curve, group input, and we will use the exact same radius. And we are going to connect it with our join geometry node. No, that was the wrong one. That one. Yes, there is now an icon because we can't shade a curve to smooth, but we will change that soon. So now we will use an instance on points node to distribute our blossoms on that circle. Instance on points node. And now we have to connect the output from our blossom custom shape with our instance on nodes. But first of all, we have to make a separate join geometry node, because if we would use now that join geometry node output, we would also use the flower middle pollen thing. So let's create a new join geometry node, and I think we can disconnect that one now. And we will use that join geometry node as input for our instance node. It's a little bit messy. Move that a little bit forward. I think something like that. And let me check my notes. The next thing what we want to do is to rotate our instances around that circle, because at the moment they are all at one place. And to do that, we will need the rotation, but the problem is we cannot use some kind of rotate Euler or something like that, because the curve itself, it has no edges or normals, but we can still achieve that with a curve to points node. Curve to points node, where is it? Curve to points node, because the curve to points node, that will give us the tangent and the normal and the rotation of each point. We connect the curve to circle with our curve, and the points go into points. And now we can use, let me take that to the left, and now we can use a rotate Euler node. And if we connect the rotation with the rotation of the rotate Euler, and now the rotation output with our rotation, you can see they are already they now are rotated pretty evenly, and they are rotated in the wrong direction. And to change that, we will insert a rotate instance node after our instance on points node. And now we can change our leaves by changing, I think in that case it's the X rotation. Yes, that's true. And I think we can leave the rest. We don't need anything else. With that value here, you can later close your blossom, but we can leave that at the moment with something like that. But of course that is the rotation is too even, and we want to change that. And first of all, we are going to add a vector math node, which we set to add, and we're going to add to that even distribution, we are going to add some random distribution. And to create that, we will need a random value node. And now you can see you can change the start random rotation and the end random rotation. But of course that is too much, and maybe we will start with 0.5 and minus 0.5, but I think that's still too much. Maybe minus 0.2 and positive 0.2. I think that looks better. By the way, you can now control the amount of blossoms with that one here, with the curve to points node. And of course the blossoms are way too big, and you can change that with the scale. We will do that soon, but first of all we are going to make that control here a little bit easier. To have one control for the blossom, we are going to add a combine XYZ node. We will need 2 of them, and we need a value node, or we can also use a group input. And first of all we have to change that from float to vector, because we want to influence each axis of our blossoms. Now connected with the vector of the add, and I think we can use the values minus 0.2 and positive 0.2 connected with these 2 vectors, and you can see you have now a blossom that looks pretty cool randomly and natural. And now to control these combine XYZ, we can connect we'll use the Y channel connected with an empty slot, and with the Y channel we have now the control about the blossom, if it's closed or not. And of course now everything has the same value, and to make it a little bit more different, we will add a math node and add it to the lower one, to the upper one, and we can add some small value only. No, that's too small, maybe 0.4. And now you have control about the blossom, and it's still randomly, and you can control even the randomness when it closes and opens. A little bit too much. We will go with 0.5 I think, and we're going to open it. And before we are going to continue to model our blossom, our flower, I think we have to change the scale of our blossoms, and to do that we can also use a random value node and plug that into our scale. And I think we can, what is a realistic value, I think 0.52 and I think 0.2. That looks pretty normal, I think. And now you can change with the flower with the radius input, and I think that looks already pretty cool. If you now activate the stem of our leaves, you can see there is also some kind of stem. I don't know if that makes sense. Now you can play with these values, and you can see you can make some pretty different flower shapes with these little controls. I will turn it off for the moment right now. And what we are going to do now is to add a stem for the whole flower that can also bend. But first of all, we are going to create another set material node. Set material node for our flower middle thing. I forgot that. And we are going to make a frame around our distribution, blossom distribution node tree. Hit F2, distribute blossoms. So now we are going to create the stem of our flower, and to create that we will go to the right of our blossom distribution frame, and we will need a curve line. Curve line, where is it? There it is. And we will need a resample curve. With the resample curve node, we can define the resolution of our stem. That can be, we can leave that at 10. And the endpoint will be at, I don't know, 0.15. That's about 15 centimeters high. Maybe it's too high for flower. I think 10 centimeters, that's okay. Connect the curve line with the resample curve, and we will need the output. We will create a join geometry node right at the end, and we will connect our resample curve node with that join geometry node. And now where is it? There it is, our little stem. I think we can, for the sake of the tutorial, we can for that moment disconnect our flower so that we only can see our stem. There it is. And now we are going to bend it, and therefore we will need a set position node. And to bend it, that's pretty much the same node tree as I used in my previous flower tutorial. I will also put a link in the description below. We will need a vector math node, and we want the position of every vertex of our curve line. And we need the index number of each vertex point. We will need a math node. There is math node, which we set to multiply, and another math node which we set to divide, and that is only because that parameter is very sensitive. And again, type in 100 and it's divided by 100, that value, and that will give us a better control about the stem bending. Now connect the index with the upper value, the divide node with the lower value, and multiply with the, no, sorry, we don't need a vector math node, we need a vector rotate node, sorry. So connect the multiply with the angle and the position with the vector. And very important, change axis angle to x-axis, or the other axis which to which you want to bend your stem. And now connect the vector with the position node. And as you can see now, we can bend our stem. Now next thing we want to do is to give our stem some kind of thickness. First we are going to make a frame around it, Ctrl J, F2, and we are going to rename that stem. And that little section here we are going to rename stem bending. and let's give it another color. So now let's move on to the thickness of our stem, and to do that we will need, of course, a set curve radius node. First of all, set curve radius node, and we will need a curve to mesh node. Curve to mesh node. So first of all let's give it a thickness so that we have some visual control about what's going on, and we will need a curve circle node. That will be our profile for our mesh, and just connect it with the profile curve and select fill caps. And of course it's way too big and we don't need that big resolution. And the radius we are going to use we will need another math node because it's again it's a very sensitive parameter. We will go with 100 again, set this to divide, and this one will be 0.51, and now we can connect it with our radius, and that looks pretty much like a stem shape. And with the set curve radius node, maybe we can drag and drop that to the lower one, to the below that line. Otherwise it looks a little bit messy. I don't like it when the lines are crossing. And now we can want some control about the thickness of our stem, and to create that we will use the Z curve radius with a color ramp node. And spline parameter node. And the spline parameter node gives us the control from the beginning to the end, and the black color will be something like 0, or was it 1? I don't know. And the white color will be the opposite, so 0 and 1, or 1 and 0. And if we now connect the factor with the factor input and the color with the radius, we can see that it's affect the radius of our curve from the beginning to the end, but we want to make it thick at the beginning and a little bit thinner at the end, so we have to invert it, something like that. And that's a little bit too thick now, too thin now, so we go select the black, and we will go with something like middle white, I think. Yes, that looks okay. And I think we don't need some additional smoothness with subdivision, but we will need a set material node and plug that right at the end. So now we have our stem, and the only thing that is missing right now is the distribution of our whole blossom with the yellow middle thing with the pollen just on top of our stem. And for those of you who have watched my previous tutorial with my flower, with my decoration flower, I've had some problems with the positioning of the flower on the top of the stem, and I think Wade Lee is his name, gave me some tip. He watched an Arendelle tutorial, or was it another tutorial? I don't know. And he gave me some tips, some note tips, and I will use this one. So he had that trick with first of all, we will need an instance on points node because we want to distribute our flower on the top. instance on points node, and that goes right into points. Now we can also, that was wrong. And now we want as instance, we want our flower. Can you, that's a long way to our instance. And of course we have to connect our instance points also with our geometry, and we've got many big blossoms on top all over our stem. And first of all, we are going to decrease the scale of our blossom because we did not work in real world measurements. And let's go with 0.05. And I think that is a pretty natural proportion. And now we want only the top of our instance of our instance tree, and to create that we will need endpoint selection, and we will connect it with our selection. And as we can see, we see nothing. That's because we have to invert it with our color ramp node. Oh, that was the wrong one. Color ramp node. And we can still see nothing because I made a classic mistake. Because I've turned the curve into a mesh. We can't work now with the endpoint selection because a mesh has no endpoints. We have to disconnect that one, and we will have to go right back to the Z position node right before we turned it to a mesh, and we'll use it after the Z position node. And now we should have a flower at the end. So, and what we have to do now is we have to rotate it in the right way, and there comes the expression tip from Wade Lees, I think was its name, and to he gave me the tip to use a line Euler to vector node with a curve tangent node. Connect the tangent with the vector, and the rotation output with the connect with the rotation input, and we got, let me change that to that position, and we got them perfectly aligned blossom. And if we now change the shape, let's go into another view, where it is there. The blossom is always aligned perfectly. So I think that's so far everything with our node tree. Let's make a group around that, hit F2, and we will name that distribute blossom on stem. And now it's time to look at the material. Let's change into viewport shading. At the moment everything looks white, and maybe we change first of all the blossom custom shape and give it the material that I think I called it blossom leaf. And you can see they have some transparency. Let's jump into our material. Where is it? Leaf. There it is. everything is procedural. I've created a texture coordinate node. Please be aware that I did not use the UV output. That's a common question that many people ask because the material does not work. Because standardly, if you create the texture coordinate node, it's set to UV output, but you have to use the object output. Then I've used a mapping node and a wave texture with these values, just to give it some small variations in it. You can see that, but I think you don't have to use that. The wave texture goes into a bump node. The bump node goes into the normal node. The wave texture also goes into a color ramp, and at the color ramp you can you have control about the colors of your blossom. Let me show you how it looks like if you use different colors, so that it's clear what the wave texture does. You can play around with that if you have, until you got something that you like and that looks more like the flower you want to have. Maybe that looks also pretty realistic. But back to our white flower with only some little gray in it, and also to white. And the color ramp goes into a UV saturation value that goes into the base color, and it also goes into a second UV saturation value that goes and it also has an input from a geometry node with the output backfacing, and that goes, I will explain that in a moment, and that goes into a translucent shader. And these two go into a mix shader that, and the factor is that pretty low. And as you can see, what the effect of that mix shader is, if I increase that, it's a flat and non-transparent or less transparent material. And if I decrease it, the material gets more and more transparent, because the problem is that we have no thickness on our leaves and we can't use subdivision surface. By the way, if you're planning to use a large meadow with much flowers, I do not recommend to use subsurface scattering, because that will kill your computer. In that way, we simulate that and to make that 2D layer transparent, though that it almost have the look of an subsurface scattering material, and because blossoms are very, very thin, the sun shines through it. That's my material for the blossoms, and I've also used that material for the inner part of the blossom, and also of course for the stem. That works too, and I've only changed the color slightly. So again, for those of you who want to copy that, here's the whole node tree. And that's pretty all of it. And if you want to use it on a meadow or something like that, you only have to copy that cube object into your scene and distribute it as instance on your grass meadow or whatever you want to do. By the way, at the end you can use the middle Z position to change the shape of our blossom. For example, if you use it like that, you have also some kind of interesting shape. And again, you can bend it like this, and you can change the radius until you get something more like looking like a sunflower or something like that. Let's increase the amount of blossoms so that looks more like a sunflower. So play with it and have fun. Hope you learned something, and I see you next time. Bye.